Welcome to the Tips for Success video. You are most likely watching this video as part of your Algebra 2 Honors Summer Assignment. Welcome to Algebra 2 Honors. In this video, we're going to talk about some of the traits of students who have succeeded in this course, as well as some of the skills and the strategies that will help you to be successful. Successful students in Algebra 2 had many of these traits, and perhaps used many, if not all, of the strategies that I'll be talking about in this video. This class requires you to do work consistently and independently, maybe more work for some than for others, and you will be required to call upon your prior knowledge and to learn new skills that will be introduced throughout the year. This course will help you to realize that you must be capable of using that knowledge to think creatively about unique problems, unlike those you've ever seen before. And to do all of those things, you need to be a responsible and mature human being, interested in your own learning. You should be prepared to feel frustrated at times, but also motivated to persist. And this should be enjoyable to you because you have signed up for a challenge. This quote by Albert Einstein really summarizes the gist of math for me. It's not that I'm so smart, it's just that I stay with problems longer. You may have heard that Einstein wasn't so good at arithmetic, but he had a drive, a need to figure things out. He knew how to be persistent. He took time to consider answers to questions and solutions to problems, but also to consider the problems themselves. In this class, unfortunately, you will not be solving actual problems that no one knows the answer to like Einstein did. But you will be learning facts and procedures so that you can apply them when necessary. Perhaps when you decide to contemplate quantum mechanics like he did. Persistence requires time and patience. You will need to be persistent in trying to understand the new material and applying it to solve problems that are unlike ones you've seen before. You must have strategies to deal with those challenges and to learn from those mistakes that you'll make in order to find success. One strategy is to use resources appropriately to help you. In this class, you will have access to answer keys. Use an answer key to see if you did a problem correctly, and then contemplate. Did I do it the same way as the answer key? If not, is your way still correct? Is your way more or less efficient? If you did it wrong, can you find your mistake? Did you only make one mistake? And will you remember this mistake and not make it again? If you don't know how to start a problem, don't look immediately at an answer key. First, look through your notes, look through other problems that are similar, and see if you can figure this out on your own. If your teacher tells you that you will not have a calculator for certain types of problems, then don't use it during your practice. Please don't use your calculator on your Khan Academy assignments. We expect that you would be able to do those without a calculator. Another important strategy is to know when to get help. It is important that you figure out answers independently as often as you can. Always search for the answer yourself instead of immediately asking a question. That is not to say, however, that there aren't times when you should ask for help. On the contrary, it is extremely important for students to ask questions. When you need clarification about facts or procedures, ask for it as soon as possible. This may be during a class or after school if your teacher is available. When asking for help, it is also important to make your question as specific as possible. Your memory plays a vital role in the level of success you will have in a math class. Even though knowledge is typically accessible everywhere, especially now at our fingertips with smartphones, our memory helps us to do things quickly and connects us to past experiences to help us make sense of new experiences. Your memory is your toolbox. Honor students typically have faster and more accurate recall functions. Students with diagnosed disabilities typically need more time for their brains to recall memories and to process information. And that is why you may see some students are allowed extra time on tests, even though there is a strict no extra time policy in honors math classes. Recall is just another word for remembering. You must be able to recall facts you have learned, mistakes you have made, problems you have solved, and solutions you have come up with. It is important that you are able to recall facts, such as the times table, and you have to do so quickly and accurately so that you can spend your time on more challenging aspects of problems. You may have gotten by temporarily memorizing information in the past, But as you progress through courses in this calculus sequence, the number of facts and procedures that you must be able to recall is so large, you couldn't possibly get through the course having to relearn facts from algebra. The fact of the matter is, you need to know stuff. And that is why the third tip for success is knowing rules and procedures. Rules we are considering as the math facts that tell you what you're supposed to do. However, it is just as important to know what you are not allowed to do, especially since those are the common mistakes that are made. Procedures are the ordered steps that you take to complete a task, such as how to divide two numbers. Okay, let's talk about some of the specific rules that you must know extremely well to be ready for Algebra 2 honors. Exponent rules are simple, yet something that many students often get wrong. So in this example, we are multiplying two exponential expressions. They have a common base of 3, and the rule says that we should be adding their exponents and keeping that common base. So the answer to this one would be 3 with an n plus t in the exponent. But that rule also works in reverse. And that's something that we often don't pay enough attention to, is that we're so used to going from one side of an equation to the other, we forget that equality should work in the opposite direction. So in this problem, we could actually break this up into 2 to the k times 2 to the 5th. And that means that this is really 2 to the k times 32. So we could rewrite this, and typically we put this as the coefficient in front, as a 32 times 2 to the k. Very different looking compared to where we started, but these are equivalent. And here's an example of a rule that we really should know backwards and forwards. Like I said, there are many common mistakes made with exponent rules. This one actually isn't so much about the exponent, it's more about order of operations, or you probably think of that as PEMDAS. This is not the same thing as 6 to the x, right? I see a lot of students often make this mistake. Here, you have to remember that in order of operations, I'm going to write down PEMDAS, that exponents have to occur before multiplying does. So if we come over here and do this multiplying, right, that would be breaking the order of operations, and that is why that's not allowed. So some other common mistakes that happen with exponents is when we're raising a binomial, that's either the sum or the difference of two terms, to some type of exponent. So in this case, we're squaring x plus 3. A common mistake would be to say that this equals x squared plus 3 squared. That is not the case, though. All right, we don't want to make that mistake. I think I've heard that this is the most common mistake on the AP Calculus exam, even. When we see a binomial being raised to a power, what we need to do is to expand that out. So in this case, we have x plus 3 times x plus 3, and then when we need to actually multiply those things. And you might use FOIL, or sometimes people call it a box to organize their work, right? But it's where every term in the first expression is multiplied with every term in that second expression. So we would get x squared plus 6x. Plus 9 is the answer, not x squared plus 9. And then the going along with that is that you can't take a square root of a binomial and square root each of those individual terms separately. So that does not equal a plus b. Do not make that mistake either. There are some rules that we pretty much take for granted. We think, it's pretty simple. Maybe it wasn't so simple at the beginning, but now you're like, okay, I think I would be fine with combining like terms, right? Don't be so sure. So you have to really pay attention to structure. When you're looking at the sum or difference of terms, do they actually have something in common? So in this example, each of these terms has a 5 to the k. In other words, it's the GCF of this expression. So you could think of it in two different ways. We are adding 4 of the 5 to the k's with another 2 5 to the k's, and we get a total of 6 5 to the k's. The other way of thinking about it is factoring out a 5 to the k, and that would leave behind a 4 plus 2, which is the 6, right? You'd get to the same answer. In this example, you might think of squaring these binomials, especially since we just talked about how that is how you're supposed to do this, right? Expanding them out and then multiplying, but not so quickly. We have to notice that on both of these terms, there is an x minus 1 being squared. Here we have 1 of them, and here we have -3 of them, which would make a total of -2 x minus 1 squares. So combining like terms, don't just think of as which things have x's, which things have y's. Those like parts can be a little bit more complicated than that. It's also very connected to the greatest common factor, as I mentioned before. So let's go back to elementary or middle school, whenever you worked on greatest common factor, and really think about how you determine the greatest common factor. When it's just numbers, you want to break each number down into its prime factorization. And so what I mean by that is if we take 30 and we think of two numbers that multiply to it. So let's do 2 and 15. And then you keep breaking each of those numbers down until you get to prime numbers. So 2 is prime, 15 is not. Let's break 15 down into 3 and 5. Okay, now 3 and 5 are prime. So notice that the ends of these branches here give us 2, 3, and 5, which if we multiplied them all together, we would get 30. So the prime factorization of 30 is 2 times 3 times 5. Let's do that for each of the other numbers. 78, we can break that down into 2 times 39. 2 is prime, and 39 is 3 times 13, each of those being prime. So the prime factorization of 78 is 2 times 3 times 13. And then lastly, 42, we could break that down into 2 times 21, and 21 is 3 times 7. We have all primes now, so 42 prime factorization is 2 times 3 times 7. So the greatest common factor is the product of all of the prime factors that these numbers have in common. So they all have a 2 and they all have a 3. So in this case, our GCF would be 2 times 3, which is 6. So let's apply that now to some more algebraic type examples. A lot of times you won't be asked to find the GCF. It will be more of a simplifying type of question. So looking at this expression, and if you were asked to simplify it, it's basically, can you combine anything here? Is there anything that they share, right? And when you're looking for things that they share, you're really looking for the GCF. So let's break this down. -1 to the k, that's -1 multiplied by itself k times, right? So there are k of these. And then that's going to be multiplied with a k and a k plus 1. And then over here, we have this -1 to the k plus 1. So it's a bunch of -1s like over there, except this time there are k plus 1 of them. And we have a k plus 1 times k plus 1. So let's circle, let me change colors here. Let's circle the common prime factors. I have k of these -1s, and I have one extra one, so we'll leave one of them out. And then here I have a k plus 1, here I have a k plus 1. So it looks like our GCF is -1 to the k plus 1. So if I factor that out of the first term, right, looking here, the only thing that's left over is a k. And then if I factor this GCF out of the second term, I'm left with one of the negative ones and one of the k plus ones. So that leaves behind the k, and then we're going to add that with the negative 1 times k plus 1 from over here. Here's the GCF out in front. Here's the term left over from the first term, and here's what's left over from that second term. And then we can continue to simplify that. So here we have negative 1 to k times k plus 1. Inside of here, we have a k plus negative k minus 1. So those k's cancel, and we just get a negative 1. Oh, but here that's really a negative 1 to the 1. Over here, we have a negative 1 to the k. That's a total of negative 1 to the k plus 1. And then there's that k plus 1 over here. So that complicated looking stuff at the top simplifies into this on the bottom if we recognize what the GCF is and can factor it out and clean up the rest of it. Okay, so let's go back to some of the important tips that we need to know for this course. This is actually a picture of my trainer, Lindsay, and one of my current personal goals is to reach a healthy weight and get stronger, and I went to Lindsay to help me with that. I really didn't know much about proper nutrition, and I knew almost nothing about lifting weights when I decided to make this my goal. I really needed Lindsay to tell me what to do to achieve my goal. And Lindsay is the expert, right? You can tell she knows what she's doing, and I depend upon her to show me what I need to do. So she demonstrated every exercise that she asked me to do and told me how many grams of protein to eat every day. Now, imagine that I just asked Lindsay to lift the weights for me and expected to get stronger just by doing that. And on top of that, let's say if I wrote down everything she told me to do with my nutrition, right? How much to eat, what to eat. Except I never changed my eating habits, and yet I expected to lose weight. Both ridiculous expectations, right? I will not get any closer to my goal by watching her exercise or listening to her explain how to exercise or how to eat. She can help me, but in the end, I only benefit from my time with Lindsay if I help myself by doing what she tells me to do. So what does that have to do with math? That brings us to our fourth tip. You really have to know how to help yourself. You must do practice problems to identify what skills you need to practice more and to see which ones you have success with. Once you've identified what skills you need help with, you must do practice problems correctly again and again and again to be able to have the recall necessary to be successful on tests. Do every problem that we give to you. Assign yourself more if you weren't successful completing the other ones multiple times in a row. Work with your teacher to create a list of tasks to complete in order to improve those skills. But remember, in the end, it comes down to you doing them. Just like a doctor. If a doctor gives you a prescription, tells you to do something, and you don't do it, you cannot have a reasonable expectation that something is going to change. Every month, I take a strength test and a mile test, and I set goals for myself. And I practice running a mile a few times each week, and I track my progress. So when I show up for my test, I know before I ever start running if I'm going to reach my goal or not. And that's because I know that I was able to run that fast in practice. When it comes to tests, I hear a lot of students say that they're going to read through their notes to study. I'm going to make a study guide. You know, while it's a good idea to read through your notes or to rewrite them or rewatch the videos to refresh your memory, you know, it's good to see those facts and procedures. But doing only that to study really is truly the equivalent of watching Lindsay lift the weights. Sure, you know, you might see proper technique, but in order to get stronger, I have to lift weights and you have to do practice problems. It's as simple as that, but it's also important to remember that simple doesn't mean that it will be easy. As this comic depicts, We sometimes get so caught up in doing what needs to be done that we don't even contemplate improving the way that we go about accomplishing those tasks. Improving how efficient we are is really just as important as completing the task. We often find ourselves favoring one way of doing things over another. It's comfortable and it feels easier to us. It may feel more difficult to do something in a different way, but in fact, that different way may actually be easier in the long run. And that brings us to our fifth and final tip. Be efficient. When we consider efficiency in math, we really are talking about minimizing the number of calculations that we need to do, the time it takes to complete them, or the number of steps it takes to solve a problem. This isn't to say that we will only accept one correct method of solving a problem. On the contrary, we encourage creative problem solving, but we do stress the importance of efficiency, since tests are timed, and in the real world, you need to meet deadlines. Efficiency is valued, period. So let's talk about some examples here. Like, what do we mean by being efficient? What if I asked you to simplify this? I mean, you're probably staring at this going, oh my God, do I have to do I have a calculator? No, you don't have a calculator. You have to be able to think about a good way of doing this problem. And I'll tell you right now, that wouldn't be multiplying 100 and 99 and 98 and 97 and 96 and 95, right? There's got to be something else that we can do here. That's why I'm bringing this up. So here's what I mean by efficient. You have to know your rules well enough in order to be efficient. I know that when there's a bunch of things being multiplied on the top and a bunch of things being multiplied on the bottom, right? But there's a big division bar between those. I know that I can choose which of those I want to do first. Multiplying and dividing, right, don't have to happen in a certain order. They're really actually the same operation. And we can talk more about that in class. But I can choose to do the 100 divided by 50 first. That's a much easier problem for me. I don't mind doing that. So let's do that. Let's do 100 divided by 50. And that would get me a 2. Let's see, what else could we do with this? 99 and 33, right? We could do that. 99 divided by 33, that gets us 3. Okay, I think we got some more pairs in here. 98 and 49, right? 49 goes into 98 twice. Okay, for the rest of these, it might not be so obvious, but I do know that 96 and 16 are both even. I know that 2 goes into both of them. Okay, so that means I could cut each of them in half. So let's see, 96 is really a 90 and a 6. Let's cut each of them in half. So we get 45 and 3. So 2 goes into 96 48 times. 2 goes into 16 8 times. Oh, and we're still left with even numbers. Let's do that again. Let's half the 48. Now it's a 24. And half the 8. Now it's a 4. Oh, and 24 divided by 4. Oh, that's 6. Right? So now that's taken care of. Let's see what else we could do here. Does 19, which is prime, go into 97 or 95? Okay, let's think about that. This is where I would say, let me think about the multiples of 19. 19 doubles to 38, and then 38 would double to 76, and then if we add another 19 onto that, we get to 95. So let's see, 19 plus another 19 gets me to the 38, plus 2 more 19s gets me to the 76, plus another 19 gets me to 95. That's a total of 5 19s. Perfect. So 19 goes into 95 5 times. So I've gotten rid of everything on the bottom, and look at what's left on top. Let's rewrite this. This is really just a 2 times 3 times 2 times 97 times 6 times 5. Okay, I can work with that. Let's see, all of this stuff right here. 2 times 3 times 2, that is 12. I think I want to go with the 6 and 5. Let's do a 30 there. And now we're down to 12 times 97 times 30. Okay. Let's talk about some tricks. I could see some tricks we could talk about here that are good. Let's work with the 97. What if I said that 97 was really 100 minus 3? And watch what I do now. Let's multiply the 12 and the 97. I'm going to multiply 12 with the 100 and 12 with the 3. So we get 1200 minus 36. And that's now what we're going to multiply with 30. And let's see if I can multiply that easily. Let's distribute that now. 1200 times 30, I'm really just thinking about the 12 and the 3, right? That's 36. And then we got 3 zeros on that. And then 36 times 30, I'm really just doing 36 times 3. And let's see, 36 times 3, it's going to end in an 8. Carry the 1, we get 108 with an extra 0 on the end. There we go. And now I have to do 36,000 minus 1,080. So we're in the 34,000s, and then the extra 80 brings us to 920. Not bad without a calculator. All right, next up, you have to be comfortable with point-slope form. You have to be comfortable with different types of forms, but point-slope form is really important, and you're going to see it's important this year and next year, and especially in calculus. So let's do this problem. Let's write the equation of a line that contains the points 1, -3, and 4, 9. Okay, so the equation of a line, and the reason that point-slope form, which I'm writing down right now, is so nice, is that this point here, is any point, right? So it's not like slope-intercept form, which has to use the y-intercept. So let's go to the slope here. If I'm going to find slope, slope is the change in y over the change in x. So -3 minus 9 over 1 minus 4 is -12 over -3, and we get +4. Great. So I'm going to fill in +4 for my slope. I'm going to pick this first point here to plug in. So this is my x1 and y1. So I have x minus 1 minus 3 there with a y equals in front, and boom, I am done. And I notice I'm leaving it that way. I don't care about putting this into slope-intercept form, which would be this. I don't care about it. It's not wrong, but why do it? I've already answered the question. Okay, so really get used to point-slope form. It is much more efficient. All right, it is now time to complete your training, or at least your summer assignment. So we ask that you attempt to master the topics we've assigned you in Khan Academy. You got to treat them as opportunities to solidify and pretty much refine your understanding of the content. Please don't just try to get them done. If you wind up struggling with them, please use the strategies outlined in this video to get through it. There's lots of stuff on Khan Academy. There's videos, there's hints, all right? You got to make sure that you're using those resources. It is possible for you to take the easy way out and keep guessing answers or have someone do your summer assignment for you. But what does that do for you in the long run? I'll tell you, it does nothing. You don't know if you can actually do those problems yourself. And when it comes time to move on to a harder but related topic, I promise you, you will be much more lost. So, the time has come. Will you choose the quick and easy path, a fixed mindset, complaining about difficulty, making excuses like I'm just not good at tests, perhaps blaming others for your shortcomings, maybe giving up when it's too hard? Or will you choose the more difficult path that requires time, persistence, accepting responsibility, and hard work? Well, we hope it's the latter one, as we know it will lead you to be successful in this class. Okay, everybody, that's all until August. We can't wait to meet you and help you to be successful in this course, and we hope you have a great summer. Bye.